Do you find yourself spend endless hours on tedious, repetitive manual data transformation tasks? Are you wasting your valuable time copy-pasting, reformatting data instead of focusing on what really matters, making data-driven decisions? Stay tuned as I'll introduce you to your new best friend, Power Query. Power Query is a built-in feature that helps you to revolutionize your data transformation workflow and make you feel like a pro. Hello everyone, my name is Lynn and welcome to my channel, where I share plenty of productivity tips that help professionals like you save hours of work so that you can spend time with your loved one. If you haven't subscribed to my channel, consider subscribe. In the previous video, we helped Excel Property, a small business who would like to assess their customer experience for their newly opening shop. We'll help them to create and distribute the survey. Through that, we've seen how data is collected and stored in Microsoft Forms, and how you can get the collected data to Excel. Today's video is about data transformation. We will transform the collected data from Excel's Properties customer survey into a clean, proper data set, which can be used for data analysis. And the tool we will be using is Power Query. First, we will need to address some data definition, get to know the data, and define some data transformation strategy. Then come the execution. We will extract and transform the data. We're starting with the simple transformation, and then we will go to more advanced technique. And finally, we will explore some options where you can load your transformed data in Excel. Now, before we start, you can download the data files in the link in the description below and follow along with me. Please feel free to rewind the video when you need it. Ready to level up your data transformation game? Let's dive into it. Data transformation is the process of convert raw data into a proper data set for analysis. It's like turning a rough diamond into a polished gem. It is important to perform data transformations because when we collect the data, it can be very messy and incomplete. And by analyzing the raw data directly, we might end up with the wrong conclusion. So, how do we perform data transformation? It involves tasks like cleaning and organizing data so it's become structured and consistent, handling error and missing value. Last but not least, changing the data type. No matter what you do, the end goal is to always create a proper data set for analysis. We've talked a lot about proper data set. So what exactly is it? A proper data set is like a well-organized collections of information that we use for research, analysis, or machine learning. And here are the key aspects of a properly structured data set. The data should be neatly stored in a way that we can easily read, like in a spreadsheet or tables. The table should contain columns, in other words, headers, and row, in other words, records. Each column in the dataset represents a specific aspect of the data, and it should be labeled with the meaningful names. Each row in the table corresponds to a single data point or observation, and it should not contain any error or outlier. Finally, each column should be assigned a proper data type. For example, IDs are classified as number, record days classified as date, timestamp as time, and name as text. Classifying correct data type helps us to better understand and analyze data in a later stage. Now, let's head back to Excel. This is the raw dataset we've collected through Excel Property Customer Survey. It is a structured dataset, sits nicely in an Excel table. It contains 14 columns, 1,948 rows, and it looks quite clean. Let's take a closer look to see what information we have in our raw data and define some data transformation strategy along the way.
So the first column is the ID. It represents the unique identifier of each record. It is like giving each row its own unique name so that you can easily find, organize, and work with data. Next four columns are metadata information that is collected automatically while customer filling in the form. We don't actually need them for reporting purposes. The next three columns are classic demographic information. It is very helpful for business to know who their customer are, to have a better product development plan, better sales or marketing strategy, and so on. The rest of the columns are customer feedbacks toward business. We have the recommendation score, then we have the overall customer satisfaction score. And finally, the rating of how customers feel about a specific aspect of the shop. Now that we have a good overview of our data and a strategy how we would perform the transformation, let's dive into it. I want to keep our data source separately in case there's new record added. So I'm going to start with a completely blank Excel worksheet. To connect to the data from an external source file, go to Data, Get Data, Form Files, and form an Excel workbook. Now go to the location where your file is stored. Select your data file and click Import. A navigator pop-up will appear and you can see the preview of the dataset. Now click Transform Data. This will lead you to a Power Query window where all the magic of transformation and shaping data happens. When performing data transformations, I usually follow a standard workflow. First, I would reduce the data size in terms of column and rows. It is important when you work with a big data sets with millions of rows. Secondly, I will do some general cleaning up, such as rename the column headers, change data types, and so on. Once everything is tidy up, I can finally perform more complex data transformation or calculations. Alright, enough with the theory. Let's head back to Power Query and perform our data transformation. First, we need to reduce the data size by removing the columns we don't need. Select the first column, hold Shift on your keyboard, and select the last column. Now click Delete. I'm going to do some general cleaning up, starting with rename all the column headers. Give them a more descriptive name so I can work with. Then I'm going to assign appropriate data type to all the columns. I can manually change the data type for one column at a time by clicking on the icon on the left and select the data type. Now I have to repeat the process for the rest of the columns. If you have hundreds of columns in your dataset, that might be not ideal. So let me show you a much faster way. On your keyboard, click Ctrl A to select all the columns. Then go to Transforms, click on Detect Data Type. Now all the columns have been adjusted with the appropriate data type, all in one go. We now have a much smaller and cleaner data set. Let's get started with more complex calculation. The first calculation we're going to do is to extract the age from the birthday column. So we need to calculate the difference between the year of today's date and the birthday's year. Sounds like a complex calculation, right? Not at all. With Power Query, we only need few simple clicks. Select the birthday column, go to Transform, and notice that the birthday column is flagged as a date data type, and therefore we can perform the date calculation. Click on Dates. From the list that appears, we want to extract the age. This returns the duration between today's date and the birthday. The column is now flagged as duration data type, and we can use duration calculation to extract the year. This gives us the years and the proportion of the year so far. The birthdays is now flagged as decimal number data type, and the number calculation is now being activated. We're gonna use round down to remove the decimal part. And we have our age calculated with Build Simple Click. And notice that all the transformation steps that we were working on are documented in the Apply Step panel on the right side. This really helps us to easily understand what's been done when we come back 6 months later. Now we need to classify the newly calculated age to age group, because if we leave the age as it is, the information is scattered and is very difficult to draw insight later on. So how do we do this? We can use logical conditions. So go to Add Column, Conditional Column, and then in the pop-up here, I'm gonna call the new column Age Group. Then the next step is to specify the threshold of the age group. So the condition is if the birthday column, which is now contain the age information, is less than 18, then we return the output as 18 minus. Click Add Clause to add a new condition. The new threshold value is now 25, and the output we want to return is 18 to 25. Let's add another condition. Threshold value is 30 for the age group 25 to 30. And finally, if none of these conditions are met, the output will be returned as 35 plus. Now click OK. Now we have our age group column added to the table. But notice that the value 25 to 30 is text, which is sitting on the left side, while the value of 35 is number, sitting on the right side of the column. This is not exactly what we want, right? We want the output as 35 plus and not as the number. So how do we fix the issue? So we need to first select the apply step that we want to adjust, then go to the formula bar. As you can see, here is the code that is generated automatically when we're using the input box, and we need to do the adjustment from here. So notice that the minus 18 and 35 is highlighted in green. That represents the number value. We need them to be in text format, which is in red color. So what we need to do is to wrap the 18 minus and 35 plus in the double quotation. And now hit enter, and we have our result as we want. Next, we will convert the recommendation column to the Net Promoter Score classification. The method is similar to the age group classification. So again, add column, conditional column. The new column name will be NPS, short for Net Promoter Score. Now we'll input our logical condition. So if the recommendation score is less than 6, then it is a detractor. If it is greater than 9, then it is a promoter. Otherwise, it is passive. Actually, the operator is less than and equal. So I'm going to change it. Same for the second if statement. Now hit OK. And we have our NPS column with the correct classification. For the customer satisfaction score, we have good score is 4 to 5 and bad score is 1 to 3. So again, applying the same methods, add column, add conditional column. The new column name will be CSAT, short for customer satisfaction. The condition would be if the overall score is greater or equal to the value 4, then the output is good. Everything else will be classified as bad. Now hit OK, and we've completed all the necessary calculation. As a final step, we're going to clean up this data set by removing any column that we don't need. So on your keyboard, hold the Control key. Now select the column we don't need. Click Delete. Now we're ready to send this cleaned dataset to Excel for analysis. So go to Home, Close and Loads, select Close and Load to, so that you have the control on where you want to load your data. Now a dialog box appears, allowing you to select how you want to load your data. You can load your data as a physical table in the Excel worksheet, a pivot table, or pivot chart. Or you can just load your data as a connection to your source. If you select to load a physical table or pivot table, you will need to specify where the output data will be in an existing worksheet or a new worksheet. I'm going to go with table and existing worksheet. Cell A1 is the location where my data will be loaded. That's look good. I'm going to click OK. To change where you want to load your data, in the Query Connection panel, right-click on the query and choose Load to. The same dialog box will appear and you can now update your preference.
I hope you enjoyed the videos. The key takeaway from here is to first understand your data, what information you have, how your data is structured, and how you want your proper data set to look like. This practice will help you to define a good data transformation strategy, which will help you tons of time during the development stage. And of course, when it comes to execution, Power Query is your best friend. With Power Query, it's very easy to perform extract, transform, and load data without writing any complex formulas. And with the magic of automation, you can kiss the manual time-consumer data cleanup task goodbye. And you can now focus your times and energy to do more value-added tasks, like getting actionable insight from the data. And that's exactly what we'll be doing in the next video. We will explore how to bring this cleaned, proper data set to life. And I will show you how you can analyze this data set to derive meaningful insight that will help drive decision making. Thank you for tuning into another insightful data journey. I hope you found today's content informative and helpful. If you do, please share it with others who might find it useful. If you enjoyed this video and want to stay updated with the latest content, don't forget to hit that like button and subscribe to my channel. I love to hear your thoughts and suggestions, so please leave a comment below. Tell me what you think. what topic you would like to see in the future, or share your own tips and tricks with the community. And of course, be sure to check out other videos in my channel to expand your data and Excel knowledge.